Hello, good morning. Jai Hind friends. Today we are going to learn Chapter 2 Polynomial of NCERT. Let us discuss exercise 1 2.2 of NCERT. Question number 1. Find the number of zeros of the polynomial and verify the relationship between the zeros and the coefficients. Let us take first part of it. First part. Here we have given x square minus 2x minus 8. Here we know that the factors of 8 are 4 cross 2 is equals to 8. We can take it as like this: x square minus 4x plus 2x minus 8. Take x common from it. We get x minus 4 plus 2 x minus 4. Then we get x plus 2 and x minus 4. We can write x is equals to minus 2 comma 4. When we take x is minus 2 is equals to 0, we get value of x is equals to x plus 2 is equals to 0, we get x is equals to minus 2, and when we take x minus 4 is equals to 0, we get value of x is equals to 4. Therefore, the number of zeros of this polynomial is minus 2 and 4. Minus 2 and 4. And we know that the sum of the zeros is alpha plus beta is equals to minus b by a, where alpha plus beta, we know that the polynomial is in the form of ax square plus alpha plus beta of x plus alpha beta is equals to 0, where alpha plus beta is equals to minus b by a. We know that our polynomial is in the form of ax square plus bx plus c. We take the value of alpha plus beta is equals to minus times b by a. Minus, we know that our polynomial is x square minus 2x minus 8. Now put the value of minus b here, we get minus times of minus 2, and the value of a is 1 here. We get alpha plus beta is 2. Now product of zeros is nothing but alpha. Product of zeros is nothing but alpha beta. The value of alpha is, we have taken 4, and the value of beta is minus 2, which is equals to minus c by a, which is equals to c by a, constant term c upon a, the coefficient of x square. C is nothing but our minus 8, and the value of a is 1. Similarly, 4 into minus 2 is also, we get minus 8. Therefore, these two terms are equal, and we get the product of zeros is equals to minus 8. Hence, the relationship between the zeros and the coefficient is verified. We know from here we have proved that the alpha plus beta, alpha is one root, beta is second root. Alpha plus beta, alpha is 4, beta is minus 2, is equals to 2, and this 2 is equals to this 2. Hence, we verified the relationship between the zeros and the coefficient of the polynomial. Now let us come to the next part of the question. 4s square minus 4s plus 1 is nothing but the formula of a minus b whole square. A square minus 2ab plus b square. When we put 2s minus 1 whole square, we get 4s square minus 4s plus 1, same as this. Therefore, by equating the given polynomial to 0, we get, on equating the given polynomial to 0, we get the solutions of s, which is equals to 2s. We can write this whole polynomial as 2s minus 1 whole square equals to 0. 2s minus 1 is equals to 0. S is equals to plus minus 1 by 2. Therefore, the number of zeros are, therefore the zeros are 1 by 2 and minus 1 by 1 minus 1 by 2. Therefore, the zeros are 1 by 2 and minus 1 by 2. Now, let's come to the part 3 of this question. 6x square minus 3 minus 7x. We can write this as like this also. 6x square minus 7x minus 3. 6 3s are 18. 6 3s are 18. You can write 18 is 9 2s are 18. You can write 7x as minus 9x plus 2x and write 3 as it is and 6x as it is. Take common 3 form from it. We get 3x is common. 2x minus 3 plus 1 2x minus 3. We get 3x plus 1 and 2x minus 3. Therefore, the value of x is minus 1 by 3 and 3 by 2. Here we get the zeros of the given polynomial. Now, let's verify the relationship between the number of zeros and the coefficients of the polynomial. Sum of the zeros is nothing but alpha plus beta. Alpha is our minus 1 by 3 and beta is 3 by 2. On adding these two terms, on adding minus 1 by 3 and 3 by 2, taking LCM of these two terms, we get 7 by 6 as our answer, which is equals to minus coefficient of our x is 7, coefficient of our x is minus 7, coefficient of our x is minus 7 and the coefficient of x square is 6. Therefore, we get 7 by 6. With this answer is equals to this term. Therefore, our relationship is verified that the sum of zeros is equal to minus b by a. The sum of zeros is equals to minus b by a. And also the product of zeros is equals to minus 3 by 6 and this minus 3 by 6 constant term is minus 3 and the coefficient of x square is 6. This term is equals to this term. Hence, the relationship between the zeros and the coefficient is verified. Now, let's come to part 4 of this question. We have 4u square plus 8u is equals to 4u square plus 8u plus 0. Here we have taken u, the constant term is 0 because the constant term is not mentioned in this problem. Therefore, we have taken the constant term as 0. We take u common from this term, we get 4u plus u plus 2. On equating both sides by 0, 4u square plus 8u is equals to 0. One value of u is 0 and another one is minus 2. Therefore, the two roots of the equation is 0 and minus 2. And we know that the sum of the zeros 0 plus minus 2 is equals to minus 2 and the coefficient of x is our 8. This minus 2 is equals to, on putting the value in the formula, alpha plus beta is equals to minus b by a. Alpha is our 0, beta is minus 2, which is equals to minus coefficient of b is 8, coefficient of a is 4. Minus 2 is equals to minus 2. Hence, the relationship between the zeros and the coefficient is verified. Similarly, the product of zeros, 0 cross minus 2 is equals to 0 and the constant term, we know that the alpha beta is equals to c by a. Alpha is 0 cross minus 2 is equals to c. The value of our c is 0 again and the value of a is 4, which is equals to 0. Therefore, this 0 is equals to this 0. Hence, the relationship of zeros and the coefficient is verified. Now, let's come to part 5 of this question. Here we have given square minus 15. On using the formula, we know that the formula a square minus b square, a square minus b square is equals to a plus b and a minus b. On putting the value in the given formula, we get this equation a minus b, a plus b. Since the zeros of the polynomial are same as root of the given quadratic polynomial, t is equals to root 15, t is equals to minus root 15. Now let's come to the sixth part of this given question. 3x square minus x minus 4. On solving the given questions, first we find the roots of the given polynomial. And the given polynomial is 3x square minus x minus 4. 3 4s are 12. 3 4s are 12. We can write 12 as minus 4 plus 3x. Here we find the root of the polynomial minus 3x square minus 4x plus 3x. Then only we get the minus x minus 4. On taking x common from here, we get 3x minus 4 plus 1, 3x minus 4, x plus 1 and 3x plus 4. Therefore, the value of x is equals to minus 1 and minus 4 by 3. Therefore, the roots of the given polynomial are, zeros of the given polynomial are minus 1 and minus 4 by 3. Hence, we know that the zeros or sum of the zeros of the polynomial, minus 1 plus minus 4 by 3 equals to minus b by a. The value of b is minus 1 and the value of a is 3. On taking the LCM, we get here minus 3 plus minus 4 is equals to 1 by 3. Here we get the zeros of the polynomial is 3x minus 4. Here we get a 3x minus 4. Therefore, the value of x is 4 by 3 and minus 1. Therefore, the value of x is 4 by 3 and minus 1. On adding these two terms, we get 4 minus 3 is 1 by 3. Therefore, we get 1 by 3. Hence, similarly, we get the product of the polynomial alpha beta is equals to c by a. Hence, the relationship between the zeros and product is verified. Alpha, the value of alpha is 4 by 3 and the value of beta is minus 1 and the value of c is minus 4 and the value of a is 3. Therefore, from here we get minus 4 by 3 is equals to minus 4 by 3. Hence, this relationship between the zeros and the product is verified. Find the quadratic polynomial each with the given number as a sum and the product of its zeros respectively. Here the number of roots of the equations are given and we have to find the polynomial of the given equation, given roots. Let alpha and beta be the two roots of the quadratic polynomial p of x. Let us consider some polynomial p of x, and p of x is equals to a times x square minus alpha plus beta, sum of the roots, and alpha beta, another one root. A is there non-zero, some non-zero term. We can write it as like this. First root is our 1 by 4. First root is our 1 by 4. We put the value of 1 by 4 in place of alpha plus beta like this. Second root alpha beta is equals to minus 1. We put the value of alpha beta is minus 1 here. On taking their LCM, we get 4x square minus x minus 4. upon 4. As on taking a is equals to 4. In order to cancel this 4, we take a, the value of a is equals to 4. On taking a is equals to 4, we get the quadratic polynomial this. On taking the value of a is 4, and we get equation up to here 4x square minus x minus 4 upon 4. This 4 cancels. Therefore, the quadratic polynomial we get this 4x square minus x minus 4. Similarly, next question. Let alpha, we know that here we have given two roots, root 2 and here we have given two roots, root 2 and root 2 and 13. Here we have given two values. Here we have given two values, root 2 and 13. Root 2 and 13 are the two roots of the polynomial. We have to find a polynomial for this roots. Let us consider p of x be any polynomial. The roots of this polynomial, one root alpha plus beta is equals to root 2 and another one root alpha beta is equals to 13. Let us find the polynomial for the given roots. Let a be the non-zero, any real number, non-zero any real number. On finding this root, we get x square minus root 2. We put the value of root 2 in place of alpha plus beta and the value of 13 in place of alpha beta. We get this equation. On taking a, the value of a as 3, we get the quadratic polynomial as 3x square minus 3 root 2x plus 3. Let us come to the next question. We know that here the alpha beta are the roots of the quadratic polynomial p of x. Let us take some quadratic polynomial p of x. P of x, ax square minus alpha beta plus alpha beta. Here p of x is equals to alpha beta is nothing but the sum of zeros, one root, which is equals to minus 1 by 4, which is equals to minus 1 by 4 minus 1 by 4, and another one root is 1 by 4. On putting the value of alpha plus beta minus 1 by 4 in this polynomial and the value of 1 by 4 in this another one root, we get this minus and this minus gives us answer plus, and 1 we put in place of alpha plus beta, we get 1 by 4 of x, and 1 by 4 is our constant term. On taking the value of a is equals to 1, we get our quadratic polynomial as x square minus x plus 1. We know that alpha beta is the root of are the zeros of the quadratic polynomial. Then we know that alpha and beta are the zeros of the quadratic polynomial. Let us take one quadratic polynomial. This a is a non-zero real number, alpha and beta is a root, and the alpha beta is a product of the roots. On putting the value of alpha plus beta is 0, on put the value of alpha beta in the given polynomial, we get here, put it here, we get answer as 0 and root 5 as a constant term here. We get x square plus root 5a. On taking the value of a is equals to 1, we get the polynomial as x square plus root 15. We know that if alpha and beta are the zeros of the quadratic polynomial, then we know that the general quadratic equation is like this. The general quadratic equation is like this. The sum of the zeros, sum of the roots of the equation alpha plus beta is 1, and the product of the roots is alpha beta is 1. Hence, the quadratic polynomial, on putting the value of alpha plus beta in place of this term and the value of alpha beta here in this term, we get our polynomial is x square minus x plus 1. On taking the value of a is equals to 1, we get the equation of our polynomial is x square minus x plus 1. We know that alpha and beta are the zeros of the quadratic polynomial. Here, we know that now the general equation of quadratic polynomial is this: p of x, ax square x minus alpha plus beta of x plus alpha beta, where a is some non-zero real number. Now, the sum of the roots alpha plus beta is equals to minus 14, and the value of alpha beta is 14. On putting the value of minus 14 in place of alpha plus beta and the value of alpha beta 14 in place of alpha beta, we get our polynomial as like this: a x square plus 14x plus 14. Where on taking the value of a is equals to 4, we get the quadratic polynomial as, which satisfying the given condition, as 4x square plus x plus 1. We know that alpha and beta are the zeros of the quadratic polynomial. Here, we know that the quadratic polynomial, our general equation of the quadratic polynomial is like this, where a is non-zero real number. Sum of the roots of the equation is alpha plus beta is 4, and the product of the roots is 1. We take minus 4, we take in place of alpha plus beta, we write as 4, and the value of alpha beta as 1. X square minus 4x plus 1. On putting the values, we get our polynomial as like this. On taking a is equals to 1, the value of a we take 1, then we get our polynomial as x square minus 4x plus 1. Thanks for watching. Don't forget to like, share and subscribe the channel.